Otherwise, I don't think that it's only if he was that we have made sure that if people so you might be able to do that. I don't know if that's this is just how I kind of go now. Sorry. There's a lot of people string. See the figures on the string. If you have it as a blow, they want it. Really, they need to get outside of your that's the biggest thing. You don't capitalize a lot. So,
That's what I have down. And I started looking at it going, no, I got it wrong. Okay. I would try to myself. Like, it can't be right. Okay, so I'm counting Reese and Daniel absent.
Reese is driving, so he will not be able to.
Oh, okay, so that's why he can't. That makes sense. He was like halfway here and realized he didn't want to come the rest of the way.
He was here this morning, that's why.
Oh, he was.
Yeah.
He was heading home. Getting bad. Well, according to MoDOT, we're all clear, but you know, sometimes MoDOT's idea of what's slick is a little different than ours. Let's take a look here. I was looking at the grade book. How's everybody doing on that last week collab document? Any questions? I said bring them with you.
I have been able to work on it all. I've been working full time, and in my free time, I've been trying to film for a video on my class.
Then you don't have any questions about it because you haven't looked at it. How about the rest of you? Questions, or should we move on to other content? This is your opportunity.
I had a hard time with the for function.
With what?
The for function.
Oh, okay. Where would be a good place for us to look? Oh, here's one. The floor and ceiling functions. Let's take a look at those. And we're going to talk about those a little bit more in this chapter too. This next chapter that we're looking at, chapter 6, it's kind of a weird chapter because all of it that I was going through feels like we've already talked about all of it. So we're going to come kind of quick through it, but give you guys time to work on it and make sure if you come up with any questions or not. So in our textbook, they talk about these different functions, the floor function, the ceiling function, the inch function. I'll tell you what the easiest way for us to figure it all out is for us to just open a Python window. Yes?
Have you shown your screen?
I haven't, thank you. I will do that. That's actually how I was gonna start out class. Help me, you guys. All right. I appreciate it. We're to that point, I don't know, you guys will start seeing it in some of your other classes. You'll start noticing that some of your instructors just quit posting new things to Canvas and it just kind of disappears and there's never anything new. The teachers get really tired this time of the semester. So you have to keep a watch for it. So I need your help whenever you're watching things, Discord messages, me not sharing, things like that, please let me know. One thing that's been a problem for me this weekend is posting the Zoom videos. I've had a lot of people send me messages asking for the videos to be posted to YouTube. And I just want to kind of clarify that I only do that when I'm able. So that is not like a guaranteed thing. And there is a lot of processing that goes on, time involved in letting Zoom process the videos and then uploading them to YouTube. So sometimes they may get behind. So if you send me messages asking about it, what does that do? Makes me further behind, right? Because now I've got to answer these messages and stuff and I still don't have a chance to work on it. Now those videos are recorded to this local machine here because it is a video and it is huge. So it's not something that I can do from home. So it does sometimes get behind and that's just the way it is. And it's kind of like a lot of other things. Have you guys ever had that happen to you in the past? Your parent gets so tired of you demanding this one toy that you love so much that they just take it away from you completely, That's where I am with the videos. If I don't quit getting harassed about it, I just won't post them at all. So let's not take me there, because I don't want to go there, because I'm glad everybody wants to see them and I'm glad they're useful, but I can't have the constant harassment about where they are. So you just need to subscribe. Realize I have several different YouTube channels to keep them separate. So I can't be uploading videos for you guys at the same time I'm uploading things for the C# class, because they're different YouTube channels. So there are some things that have to happen. So give me a break. Remember, that's not at the top of my list. What is at the top of my list is getting new content ready for you guys in class the next time we have class. And you guys know we've been working with Collaboratory. This is all brand new. So I have had to spend a lot of time and effort at home getting things updated in my mind and knowing how this works so that I can give you guys instruction. So that has meant that I've had to sacrifice time that I would have allocated to grading. So again, Collab is giving you those results as a programmer. You don't need to wait for a teacher to get your grade, right? You know if it worked or not when you turned it in. Now you can still have all those worries. I understand worries about, did it get submitted right? Is she gonna see it properly? All those kinds of things. But those are just the kinds of stressors that we just have to deal with. And you have to be aware that anytime we're using new things, new features, that's gonna take away from a little bit of that standard paperwork kind of stuff. And of course, I would rather work on new things than paperwork, right? Just like everybody else. So that kind of stuff I'll get behind. So let's look at our floor and ceiling. So I can go to the Python interpreter, just type py and bring up my good old idle Python interpreter. I think it's coming up here somewhere. There it is. And I could try it. So if I type floor 3.2, I think that should give me 3, right? Oh, it's not. Do I have to use math?
Yeah.
Yeah? I have to import math? Ah, get it. 3.2. Finally, got it to work. So, floor, if we look at it, it doesn't really necessarily return an integer, right? Because it still has a decimal place, but it removed the decimal place component and just dropped it to the lower integer. So what if I did floor 3.8? That would be different, right? And no, it wouldn't, because floor just cuts off that integer part, just basically truncates the integer. Now ceiling, though, is a little different. Let me try it. Math.ceiling 3.2. Whoops, did I spell it wrong? My I before E thing.
No, it's just CEIL, that's all it is.
And now I've got caps lock on. Just a terrible mess. Well, that's really dumb, huh? So the two of them are kind of like really poorly named, right? I mean, I don't know how else we could say it. This should just be, I mean, the floor is just basically truncating off the decimal place. The ceiling is basically just rounding up no matter what the decimal value is, right? So we don't even get any sort of rounding. Didn't we have a round function? Let's see if we can try it. I want to say that it's RND. I better search Python round. Oh, it's ROUND. So now if I do 3.2, it just gripes at me. What's it say this time? Round. Do I not need math? Look at all this experimenting we can do just at the Python shell to figure everything out. So our round function is, first of all, not part of the math library, which is interesting because we can just use it without importing math. So round kind of does it the way we're expecting though, doesn't it? Let's try it with 3.8. So when we do the round, we're getting what we actually expect. If the number we try to round is below 3.5, it's going to go down. If it's above, it's going to go up. What if we do exactly 3.5? We can always check for sure so that we know. So how is that different than if I did the int function? It's not very different from the floor, is it? So floor keeps this number still as a float, where the int function turns it completely into an integer. But really, they have the same effect on our value of just getting rid of the decimal place. So in our examples, in our textbook, the Prelude to Programming book, they do a pretty good job of trying to give you some examples that actually use these functions that benefit from the fact that the ceiling just moves up a value and floor just truncates. So some of the examples they show you will give you like meaning to have those functions, but you can see as you look at them that you might not use floor and ceiling as often as you would use round, right? It's just kind of the way things are. So that's a really good question because those things are very, very similar to each other, just a little bit different. Does that make sense with those?
It does, thank you.
Sure. Let's look at some other stuff there. So we had our floor and ceiling, and in our student activity for that one, we wanted to implement that example for doing the input. So if we look at this example at the pseudocode, at what we were wanted to implement in Python, what's really important to us in Python is the while loop, right? Where we're saying if the hours are negative or the rate of pay that was entered is negative, we're going to stick in this loop and keep prompting for a new hours and a new rate of pay. So I know there was a lot in this Colab notebook. Are there any of these that we need to work on together?
Yeah.
Which one? That one? Because I was thinking this was one that we might need to work on together. Let's do it. Now, if you already have this one done, there's some other things you can do, or you can come along with us and work on it and see if you accomplished it in the same way that we do. But if you would rather look at something else, let's look at our modules first before we do this one, because I know some of you have it done. For this week, we have a new Colab notebook that's much smaller, has a few things. Chapter 5 is kind of big for us. Chapter 6 is much smaller. There's also some review questions for Chapter 6. So you can be looking at any of those if you like while we're doing this one together. Let's get it done. So I'm going to start with the student activity 16. Let's work on this one. And let me do a snip on this so I have it so I don't have to keep scrolling back and forth on you. Okay, let's start it. So I'm going to say that this one is example 5.34. Validate positive input. So we're going to say our purpose here is to validate input as positive. And with this one, they have some variables, and I know that this is like one of the most confusing areas for us in switching back and forth between the pseudocode and real code. So we're just going to name our variables to act as a declare. Oh, thank you. So we don't really have to do that declare thing in Python, but we'll say we have a sum that's going to be 0.0, and we have a number that is just going to be an integer. So if we put 0.0, we're kind of implying that sum is a float. And just by putting 0 without any decimal places, we're implying that number is an integer. Now in our pseudocode, after they declare the variables, they do set the sum equal to 0, and we've already done that. So we don't have to do any extra there. So let's prompt for a number. Now our number is going to be an integer, so we'll convert it to an integer. We want our input statement to say, enter a positive, enter 0 when done. Now looking at our pseudocode, remember we're taking care of both line 4 and 5 of our pseudocode with our input statement, because it lets us display the prompt and read in the variable data. Okay, now that we've prompted for them, we can go into our while loop to validate. So while our number is greater than 0, it's a good number, we can add it to our sum. Add the number to our sum. This sum could almost be considered a running total. And if you work like at a fast food restaurant, the manager might even come over at like 3 in the afternoon and put the key in the register or something and print out that special receipt that prints out the running total for so far today on that cash register. So a running total is a really common thing. It's just we've been keeping track of everything and we've been adding it up. Now that we've got that number added to our sum, we can ask for another number. So I can just copy this line of code, whoops, copy it properly, and paste it.
How do you paste it? Control
V.
V?
Uh-huh.
Doing that just gives me an error.
Stick it in there. And you have to just copy the selection in Colab, because otherwise it's too much if you copy the whole stuff.
The entire code and
Yeah.
paste it, so.
Just Control Z to back up. And if you Control Z in Colab, it'll come, sometimes it comes up with this weird message. Mine's not doing it now, of course, since I'm telling you about it. But sometimes it does come up with a weird message, but it should still undo. So remember, Control V is important because it pastes, but Control Z is more important because it undoes. Undo can be more important to us.
Yeah, I keep Control V, and all it does is create another cell.
Well, don't copy it. You have to copy it again then, right? because you obviously copied more than what we need. So make sure to select just this row. And what I've found in Colab, because it's kind of a pain like that, is only copy selection. Your Control C will do it. But yeah, it copies way more than you want sometimes. Now, that's all we need to do in our loop. So the pseudocode looks a little harder. And you guys are going to start saying things like that to me soon. Do we have to look at this pseudocode? Our Python code is actually easier than the pseudocode. And you're right, it is. And what we're seeing in the field in our industry is that some people are starting to use Python like instead of pseudocode because it is like a little easier. But so if we look at it, we see in our pseudocode, we had 3 lines of code in our while loop. And in our Python code, we only need the 2 because our input statement is prompting and loading up our variable. Now we need one more thing to happen after our while loop is done. We want to print out the total. So our message is going to say the sum of the numbers input is, and then we want to add in our sum. Now we know from working with things in the last couple of weeks that because that sum is numeric, we need to cast it as a string by using the str function. That should do it. Let's run it. Okay, so we're going to start out entering a positive integer, 5, 6, and then I can just enter 0 when I'm done, and I should get my total. Does everybody's work okay? Let's try it again. Now, what does our code do if we enter something that is not greater than 0? Like if I start out saying -7, oh, it just ended, right? Because we didn't go into our while loop because we weren't greater than 0. So maybe we want to actually give them a message about that. We'll work on that as we look at the examples. So in this program, it works fine, but if they enter a number that we don't like, we just ignore it and end our processing. Okay, so this one here, the next one, is really, really similar, right? It's just that in this one, we're going to have a few more variables. Let's try it. Let me get it up here so I can snip it. Now, if you guys had a chance to look at these and kind of struggle with them and not know exactly what to do, realize that's what we want. And that makes your brain really open to the idea of how to solve this problem, how to make this program work. If you don't struggle with a little bit, try to figure it out. It won't mean anything to you. You'll just copy the code down and be like, well, I just copied that code, but it doesn't mean anything to me. So remember, it's that there has to be that little bit of struggling. Our brains are just built that way. If things are easy, we don't remember them. We just pass on by. It's only the things we really have to fight for a little bit that our brains are. Remember, that's how we're built, right? Because we don't remember happy, happy, happy things, just, oh, how nice. We remember the things we had to fight for. So do be working through these on your own, struggling a little bit. I'm going to be here to try to help you to solve the problem in the end, but it is important to do that struggling on your own. So this one, our script here is going to be example 5.35. And in this one, we're doing an exam score average. So a little bit more than our last one where we were just kind of adding up numbers. Let's see, to sum and average exam scores. We'll set up our variables. We have a count for how many grades have been entered. I'll put a comment over to the side about that. How many grades are entered? We have a sum of all of those grades. So in our comment, we can just say that is going to be the sum of all of those entered grades. We have a variable that's going to be the actual grade that is entered. So for our comment, let's say this is an individual grade. And then finally our average. And in this one, they did what so many of us do, where they started out with this really good naming convention. And then when they got to the average, they just blew it. And it happens a lot. We all do it. But of course, they should call this AVG grades, right? And it would match all of these other variable names. But we'll go ahead and use theirs. The average of all of the entered grades. Now in our code, in the pseudocode, the next thing they do after declaring the variables is set the count and the sum to 0. Now again, we've already done that with our variables, so we don't have to do that separate initialization. But it is important that before we start our loop, those variables have that initial value that we want. Okay, now we're going to prompt for the user to input a grade. Do you want your grades to allow for decimal places, or do we want them to be integers? What do you guys think? Integers? Decimal places? Let's make them a float because we keep using integers. And we need some example code with decimal places. Plus, we already said our grade was going to have decimal places. So our input is going to say enter 1 exam grade, enter 0, 1, done. So we're going to let them type in that grade, and it's going to get converted to a float and saved into our grade variable. Now, while that grade that they enter is greater than 0, we can do our looping activities. So first thing we want to do is add to our counter. So count grades. We can use a shortcut. So I could say count grades equals count grades plus 1, but I can also use this shortcut plus equal 1. And that says take that counter and add 1 to it. Now our sum of grades, we can do that same kind of thing. We can add this new grade to our sum. And then we're going to ask for another one. So let's copy our input statement. We could test at that point. We've got a lot done. Let's go ahead and try it. We have a couple more lines of code to add in our final calculations, but let's try running it right now. Enter 1 exam grade. So I'll do 53. And we got another prompt. Enter one exam grade. I'm going to try something that's a float. Make sure it doesn't cause any trouble. It seemed to be okay. Bless you. And then I'll end it. So it seemed like it's working okay. I don't have any problems there. That's good. So let's finish it up. I'm going to back tab so that I'm not in my while loop anymore. And I'm going to calculate that average. Exam average equals our sum divided by our count. And then we can output that. Your exam average is the exam average converted to a string. Now we should be able to run it, and we should get our final average out. So let's try it. We'll just try 3 numbers that I know I can get pretty close. That looks good. My average came out to 88. So in our loop, we had to initialize things before we started our loop. So we set up our variables, but it's mostly our grade variable that had to be initialized to begin our loop. And as long as our user types something in that's greater than 0, we're going to add 1 to our count, add that grade to our sum, and prompt for a new one. Think about if we had to switch that all around. If in our while loop, the first thing we did was ask for a grade, then add it to our count and add it to our sum, we would have to have if statements in here and add a lot more logic. So notice how the order things are done helps with the flow of the program, of keeping things moving cleanly without us having to do some jumping around. Perfect. Everybody's okay? Working? That looks like that was the last one. Any others causing any trouble for anybody?
Oh, I got one.
We had a lot in here for sure. What?
Nothing, I'm just looking through all this.
There's a lot in here.
We have to have all this done by today.
He started on it last week, so you might need more time.
All right.
You just spent,
I've had no time to work on this at all.
so find some.
Can we look at example 5.30?
Which one?
5.30.
Uh-huh. Sure. This infinite loop? Is this the right one, Tim?
Oh,
Make sure I can hear you.
no, 30.
0. Okay.
Sorry.
That's okay. That's why I was asking. I was like, I don't think I'm understanding. Oh, I got a typo. Another typo. So in this one, we had an example, a piece of code that was from the previous chapter, where if you remember, it had like a try and catch type code snippet. I'll have to go find it. But that's what we have to do in Python to do this sort of thing, to validate that something's an integer. So where did we have that? Let me see. I think that should have been in our previous collab document. Let me make sure. Yeah. So in our chapter 4 selection, share collab document, towards the top, it was sample code, and there's a defensive programming section. And we could really copy this to that collab document we're working on. So I will copy it, and you guys can copy it from me. So let me do that. Because we can just get pieces all over the place. Now with the text, I'm putting the 3 double quotes in at the beginning and end so that collab will, now it's still messing it up. Nope, not any better. So whenever we're saying convert something to an integer, like they're doing here in this code snippet, we have found that with Python, we would have to put the keyword try before we try to convert something to an integer. And then if it can't be converted to an integer, the code that is associated with this except statement will be executed.
Okay.
So we can't really do the test the way the pseudocode shows us. So I put this in our collab document so that you would be aware that would be how you would do it in most programming languages. But in Python, it's a little bit different. So in our situation, we will avoid testing something to see that it's a valid integer in our code, because most of the examples that we use, we don't need to worry about that too much.
Alrighty.
Because it is very unusual, very non-standard kind of code. So it was at the beginning of your chapter 4 collab notebook that I shared that has that try catch code. So just a little different. Sometimes when we're working with stuff, it can be sort of frustrating because I'll say things like that. It's not exactly the same. We won't use it a lot. That means that it's something that you can put to the back of your mind, because in our class, it could come up somewhere. And it would be nice to remember that you've seen it somewhere. You might have to start Googling or searching for it. You might not be able to get your hands on it right away. But just the fact that you can remember you've seen it somewhere is actually good enough. For us, for our needs, you don't need to actually be able to make the code work until you have an assignment that says, make this code work. And then you have to go find it and you have to go figure it out. So our field is a little different than some fields, you know, because in some fields, you're expected to remember everything that could ever possibly ever happen. But in our field, that's just not possible. So we approach it sort of like the medical field, that you know it's available, you know it can happen, but you're going to have to go do some really specific research and some really specific practicing before you can do that specific thing. So that's kind of the way our field is. It can be hard on people because we have, you know, sometimes people are like, no, I need to know everything. We can't. Our brains would explode. Just too much. So in INT, we have to test it a little bit differently. So good stuff in here. I think that if you've got code going for all of these different students' assignments, you've done a great job. I'm not exactly sure how I'm going to grade them, but I can guarantee you that I will not be clicking on every single student assignment for every single student, making sure that every single one is there. I can just pretty much tell you that.
Can we go over student activity 14 real quick?
Sure.
Okay.
It'll be 0.25 and 0.26.
0.25 and 2. Oh, there, I see what you're saying. Thank you. Okay. So let's see what you've got. Let me stop sharing. Can you share with us and let's see.
So I'm having an issue at the end of my grouping statement or my while statement. Everything up to that point works well, and then, oops. Oh, I'll start over on that. If I want to keep going, it'll just end the program. And I'm not sure what my code is causing that. You see what I'm talking about?
Yeah, so could we just have that print statement be outside of the while loop and not have an if statement?
Oh, so just like take the if statement out completely.
Uh-huh. And then make your print statement be outside of your loop, so backspace it so that it's all the, and then get rid of that break statement because you won't need it since you're not in your loop anymore now. Now let's see if that.
And then just keep going.
So whenever you're doing that second input statement, where is that input going?
What do you mean?
Where is that input going? Up here, where is that input going? We've got this input statement. Don't we need a variable to hold that input? Should it be our response variable?
Oh.
So let's say response equals.
And
Perfect. Now we need to do that same thing down here.
Okay.
Now try that.
You spelled response.
Is it spelled wrong?
There.
Somewhere. You did it. Good job. Okay.
Oh, maybe it's in the other case. No.
It should still be not, right?
Yeah.
So look at that while statement. Help me, guys. What's he done? What's that while statement got? Thank you so much for sharing because you got good stuff.
Thank you.
What's that while statement got? Can I say while response equal y or y? What's the or y part? What are we comparing to there? Does Python know that? No, we need to say or response equal lowercase y.
Oh, so I gotta put response.
You have to
equals
have it at
y.
both sides.
Gotcha.
Everybody's seeing that 'cause it's really, really good, helpful things. So common for us to do. Okay, so now let's see.
So what I had
So
to do,
things can so be confusing, right?
yeah. So when I had to do the same thing with N, the letter N, what would that be an if statement towards the end?
For what?
If I wanted to make uppercase or lowercase unacceptable to end the loop. You see what I'm saying?
You've already got it, because anything besides the Y,
We'll end it.
yeah,
Okay,
it's gonna
gotcha.
end it.
Gotcha.
Now, one question though, how come we're getting that? Do you guys like the way it asks about processing an employee before it starts?
No.
No, I don't like that. How can we make that not happen?
Can I just delete it?
You could delete it. Is that gonna work? Let's try it.
No.
It didn't. So what do we need to do to initialize, to get things set up where our loop will execute?
The variable response needs to equal Y or Y.
Exactly. So right there, response equal, just one equal,
Oh.
because we want to change its value. Either uppercase Y or lowercase y, like Tim said. And that should do it. Now, just one of them, just one
Oh,
of them.
I thought you were saying or.
Sorry, I was, but it doesn't know what
Not
that
like
means. So good.
So, okay.
Now we've got it set to where the loop will work at the first time.
Okay.
Beautiful.
Okay, cool.
Very cool. And
Sweet.
you guys, it's so good to see those kinds of problems because they're so common. And it can be so misleading when you're just starting out. You know, where is the problem? Is the problem in the while statement or the input statement? So many individual places, and we can kind of get a few problems going. So good job. Thank you. Any others? Anybody got any others that they're having trouble with that we can debug for the greater good? All right, let's look at this week's. Let's see how it's gonna work. This one, like I said, it's much smaller because that chapter 5 just put everything in there, and there is a lot to learn with looping. So there was quite a few different examples. Let's take a look at the week 10 one. And if you look in Canvas, you should see a link to it on the assignment. Our Colab IPython notebook, chapter 6. Try that link and let's make sure it takes you to the right place. Now that one, when you get it open, let's save a copy. And I've got my copy created, so I'm ready to go. In this example, in this chapter, they talk about more advanced looping syntax. But like I said, you guys have really already been exposed to a lot of the things that they talk about. So one of the sections is combining loops with if statements. And you all started doing that. I think the very first loop we tried, someone said, oh, we could make it better if we put an if statement in. So you were right on top of that. Now the pseudocode, if you notice, is getting longer. So it starts making it easier to make problems for ourselves that we can't figure out. So remember to be sure and test as you go. Make sure, you know, your input statement is working properly, and, you know, maybe even put extra print statements in your code to print things out in certain places. That would be helpful. So in this pseudocode, they're looking at giving yourself like a spending limit and then keeping track of how much money you spend. So this is somebody who's going shopping. They're really good at keeping track of their budget. So as soon as they hit their limit, they're going to stop spending and go home. I need to send this person with me. But in the end, we're going to output how many items they bought and how much they spent overall. So that's what this first pseudocode is. So in this one, we just have our loop, and inside our loop, we have our if statement to see if we've gone over. Let's do this one together. In the textbook, they also included a flowchart for us. So I put that in our collab document too. I'm going to F11 to go full screen and see if I can see more of it. I'll still have to do a little bit of zooming. Sometimes it's easier to understand what's going on in a flowchart. So I want to include them if they have them. So let's look at it graphically here. We're going to start out declaring our variables, setting our variables to initial values that we need, then doing our first prompt for input, and we're going to save that input in a variable named max. Now, after we have that input, we're going to check for our count to make sure that we haven't gone over 10 items. So we're going to make sure our count is less than 11. And if it's less than 11, we're going to ask for the cost, add the cost to our total, and add 1 to our counter. Now, if our total is going over their max, we're done. We're going to stop. Say you've bought too many things, reached your spending limit, can't buy this or anything else, and we're going to end the program. But if our total is not greater than our max, we're going to give them a message, you've bought however many items, and then ask them for the cost of their next item. So our loop will keep going until they buy more than 10 items or their total gets beyond the allowed total. We'll think about it as that way. So let me get this pseudocode snipped. And the reason I want to do this one together is because it's a for loop. So I don't think we would need to at all if it was a regular while loop, because you guys have been doing those and you seem pretty comfortable with them. But we haven't done a lot of for loops yet, and that syntax is kind of messy. So this script, let's call it example 6.1, shopping limit. Set a limit and count items. And of course, I could get like a whole story there in our purpose, but I'll keep it short. Okay, so first, let's set up our variables. We need cost and total. I'll just do all of them. How's that? Cost and total and max. All this floats. And then I want a variable named count for our integer. So with Python, we should be able to declare multiple variables on one line as long as we want them to start with the same initial value. Now for our first prompt, we're going to ask for the maximum amount to spend. So max equals, we'll change it to a float, and our input statement is going to say enter the maximum amount you want to spend. And then they put a $sign there. Now in our flow chart, we saw that they wanted to execute this loop until they'd given us 10 items, that 10 items is like our limit. So we're gonna use a for loop, because they say for loops work really good if you know what your limit is like that. So let's start out with our syntax. For is our keyword. Then we're gonna do our variable name. They want us to use our variable named count. Now, when our for loop in Python, after we specify our variable name, the type of for loop we're going to use is a range. So we have to have the keywords in range. And then in our range, we specify our beginning range value. They want us to start with 1. And our ending range value, which would be 11. And then remember that third parameter would be our step value, our increment value. And we want ours to increment by 1, so we can leave that out. So that's our for loop. Now in our for loop, the first thing we're going to do is ask for our cost of an item. I left out the input function, but we're going to convert whatever they type in to a float and then save it in our cost variable. Now, we want to update our total by adding that cost amount to it. And now we can check to see if we've gone over. So let's put a comment there. Update our total by adding this cost. If our total is greater than that maximum they gave us, we've gone over our spending limit. Put a comment there. If we've exceeded our limit, now they want to do some interesting things here if we exceed the limit. First of all, we're going to give them an error message. Print, you have reached your spending limit. And then one more message. You cannot buy this item or anything else. A little hateful there. Be a little nicer. Maybe find something cheaper. And so then what it's going to do, this is so interesting, is we're going to subtract out that cost that we just added in. So just like I can do plus equal to add that amount to the variable before the equal sign, I can do minus equal to subtract that value from that variable, those shortcut operators. And now they want me to exit out of this for loop. Well, there's some things we can do. We could try a break. We'll try that. So a break should break us out of the for loop. Because we have Python running this for loop, there's really not much else we can do, right? I mean, we can't set some variable to a value to make it stop executing because Python is in charge of this for loop for us. So we just kind of have to break out of it. Now, if we don't break out of it, we continue in our for loop. I'm going to backspace and print out a message, and this should still be inside of our for loop. We're going to print out the message, you have bought and then we're going to use our counter to tell them how many items they've bought. Yep. Good job. We're going to need to convert that counter to a string. Now, finally, our last line of code should be all the way back to column 1, all the way outside of our for loop. In this one, we're going to tell them what their total cost is. Your total cost is $, and then we're going to add the total. So we had to change things, switch it around a little bit from that pseudocode to get it to work with Python. And our flowchart also. Let's see if we're working. Let's try it. Now this one we went a little far without testing because we were going off that code that was given to us. Oh, it doesn't like me doing that. Float object is not iterable. That means I don't know what you're doing with this whole list of things because you can't do that.
How many spaces are on line 13? Just one?
Do what?
How many spaces are on line 13 when it asks you to enter the cost of an item?
Yeah, it should be none. It starts right at column 1.
Okay. I mean, it's getting a syntax error on that line.
Look at your parentheses on the line above and make sure they're all matching. Put all my variables on their own line. Try that again. Enter the maximum amount you want to spend. 2,000. Enter the cost of an item. Now, think about this when we have to do a lot of different testing, right? So for this one, let's say I want to get an item that goes over the limit right away because I want to test that code. So I'll say 1,000 and then make sure it works right. You have bought 1 items. Enter the cost of an item. I'll do another 1,000 and that should put me at my limit. But our if statement is a greater than, so it doesn't see it. So I have to go a little bit higher. I'll do another 100. And now it says you have reached your spending limit. You cannot buy this item or anything else. Your total cost is 2,000. So it seems to have worked that way. So I'll try it again. And this time I'll put in a bunch of little amounts because I want to check. Oops, I got to do that different. I wasn't paying attention. I was talking. Okay, my total, I'm going to do 2,000 again, but I want to do some small items because I want to make sure that it stops after 10 things. So I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th item. It should end. So we've got 10 items in your total cost. So that looks good. It's that requirement is being met, that it's stopping after 10 things. So everything looks good there. If we exceed our limit, we're getting kicked out. If we go past 10 things, It's saying it's done. Any troubles? Working okay? Good. So we just had that if statement inside our loop, and sometimes we might have to break out of our loop depending on our if statement. You know, if we have some sort of criteria like that. 6.2 is testing just for integers, and I told you that we would look at that code when we needed to. Looks like the time is here. I'm gonna find that thing there. This wasn't the right one. Okay, I've got it. So let's see if we can get this to work. So here we are. We've got a need to have our user enter a bunch of valid integers. So we're asking them, well, first of all, in our for loop, we're saying that we want to start at 1 and that we want to continue while we are less than or equal to 10. And every execution of our loop, we're going to ask for an integer. And if the user types something in that's not a valid integer, we're going to end. Otherwise, we're going to add it to our total. So it's going to be real similar to the one we did a little earlier, where we were adding into a sum. But in this one, we're going to have some error checking to make sure they type in a valid number. So let's see if we can do it. Here's our flowchart. Every time our loop executes, we'll ask them for a number. If it's a valid integer, we'll add it in. If it's not, we'll give them a message. So let's put some code in here. This will be our last one, I think. So this one is going to have some really, really handy code. There's going to be some stuff in here that you're going to want to refer to. So our Colab notebooks are nice in some respects, but in others, they keep our code kind of trapped too and a little bit harder to find. In your file menu, you can download as a PY file. If you check that, it'll download your whole Colab document notebook as a .py, and you'll see the Python code. Everything else will be commented out. And so that you can kind of save the whole thing that way. And I'm kind of considering having you guys turn them in that way so that I can see it a little easier. But you can definitely do that if it makes it easier for you to find things in the future. All right, so in our pseudocode, we are asking, I didn't do a snip of that, let me get it. We have some different variables again. Our count, our sum, and then our number. In our pseudocode, they say for count equal 1, count less than or equal 10, count plus plus. For us to convert that to Python, we're going to say for count in range 1, 10. Now I can say 10 here because they have greater than or equal. And that's what our ending value is, and our range is a greater than or equal. So within our for loop, the first thing we're going to do is ask for a number. We want that to be a float. So we'll prompt enter an integer. Well, I'm messing up because I can't convert it to a float here because I want to make that part of my program to make sure that it really is. And we're asking for an integer, not a float. I'm mixing things up in my head. That's no good. So now we have to try to see if we can convert that to an integer. Let's try. We'll say number equals int number. Can we convert it? Now, because we're using Python, we have to put that keyword try in front of this. And then I have to indent my line of code so that Python knows it's part of this try. Try to convert it. Can you convert it to an integer? If we can't, we'll get an exception. So I'll put that. If there's an exception, we want to print out that message. Your entry is not an integer. The summation has ended.
At the top, should we put number equals just 0 instead of 0?
Do it?
At the top, should we put number equals?
Yeah, let's do it. Python would have readjusted, but that would be unclear. Okay, now, if our number is valid, we need to add it to our sum. So we're going to backspace because we don't want this code to be within our try except clause. We want it to be within our for statement. We're going to add that number to our sum. And then finally, when we're all done, after our for loop, we're going to print out the sum of your numbers is your sum. Okay, I haven't done this before. Let's see if we got it to work. We might have to do some debugging. Enter an integer. I'm going to try a real one. 5 and 5 and 5. I forgot I was going to have to do it 10 times. We need to set that loop count lower. Okay, so that worked. I'm going to set my count to like 4 for our testing. Now I'm going to try it again. This time I'm going to enter a valid number for the first integer, and then the second one, I'm going to put in some letters. Oh, there we go. So we got your entry is not an integer. The summation has ended. Oh, but then it broke again when I tried to add that number to the sum. Should we put that line of code up here within our try? So it only adds to our sum if we have a good number? Seems like that would be a good place.
Try on line 14 is giving me an error.
Is it? Do you guys have closing parentheses above? Because remember, I had that float in there and then I took it out. So if you have two parentheses, it'll be mad. Should only have one.
I took that one parentheses that event button and I fixed it.
Here, share with us and let's see if we can tell. Show us what it's doing.
All right, good.
Someone show us. Not seeing it. Is someone going to share with us? No? Okay.
Anybody or,
What?
you mean like anybody or?
Well, whoever was having trouble with that. Has the troubles gone away then? Okay, we're going to pretend they did. All right, so we're going to say that we're going to add to our sum only if we can convert that number to an integer. So we'll put that code up here within our try. Now let's see. 5, bunch of stuff. Your entry is not an integer. The summation has ended. But it's staying within our loop, so I'm going to put in a couple more. 5, 5. I changed my comment to 4, not my actual for loop. I would never do anything like that. I'm like, why does it keep asking me? I finally got to the end. Okay, so we handled our errors. If we got a bad number, we told them that it was a bad number. And if it was a good number, we added it to our sum. So we had to do it a little bit different, though, than what that pseudocode showed and what the flowchart showed, because we had to take our language into consideration, kind of messed with us a little bit. Is it working? Everybody got it working? Okay, good. That's a really good one. Uh-huh.
So whenever I do it, it's including the non-entries as entry. So it's, I have 21 to 30. Good time.
Did you start up here with 0?
Yeah.
Let's see it. So what are 2 wrong?
is including the non-entries as an entry.
Well, if I look at the number ones that you entered in 7.
Why are we trying to get it where it's?
Well, you lost some of them because of your invalid integers.
Oh, okay.
So those ones still counted
Yeah,
in your count.
yeah. That's
So-
what I thought we were trying to.
Yeah, good question, but that's why you don't have those
Okay,
ones.
but like I assumed that's why it was, but
Uh-huh.
I thought we done something to get rid of it. And then
Nope, that's exactly the way it works. So if we were doing a while loop, we could have controlled that, right? And we could have made it stop or made it keep going if we wanted to. But in our for loop, we're kind of more at Python's mercy there. So it gives us some differences in the way things are handled. Great job. Now, a lot of the chapter is your guessing game that you guys already did with that Python beginning programming stuff. So some of it is in here again, just because I wanted you to kind of consider it again now that you know so much more, but I didn't want you to redo it, so I didn't ask you to do that one. There is one though for finding the square root of a whole series of numbers, so I will ask you to finish up that one. And then using the length. Okay, here's where I was going. Student activity 6 is a little bit different. In this one, we have listed a lot of the functions that our textbook has been showing us. The square root, int, ceiling, floor, all of these. So for each of these, I want you to do the research to determine what the appropriate equivalent Python function is. And you guys were telling me what the right function was this morning earlier, so I don't think that's going to be a problem for you. So we know for ceiling, it was CEIL, but we had to go to the math library. So in this one, how you fill it out is kind of up to you. I'm not going to be super particular, but I want you to find the equivalent Python function for all those functions that they talk about in our textbook. One of them that you're going to need is this length of. The previous assignment, the previous exercise uses the length of function. So in order to finish this one, you'll need to figure out what the equivalent function name is in Python. So that one shouldn't be too bad. And then for our nested loops, I basically just repeated that for loop syntax to remind you of the differences between the pseudocode and our Python code. Now I might have a little bit more for next time, but that's it for our collab document for this chapter. Now there are a couple other things for the chapter. Before we break for lab time, I want to show you the one. We won't have much lab time, of course. We will next time. I'm sorry the way it's working out. It's just working a lot better for me if we have our Monday day be pretty focused on new content and our Wednesday day pretty focused on our lab time. I know that's not exactly what the schedule says. What I was looking at is this Padlet code snippets. This is for your study group. So please get with your study group to fix this. And what we've got here is on this Padlet, you can go to it. You double click on it or something, you can just do it right here in Canvas. But what we're going to do is add like a comment to this for each group. And what I want in your comment is for you to identify what the output would be from this code snippet. So for this one, you might have to put it in Python and see what it comes out with to experiment with it. Or maybe you want to do some research on Google and do some desk checking and try to figure out what it's going to come up with. The way this activities normally worked in the past, and let me tell you about it, they usually had one of those giant Post-it notes all around the room with one of these if statements or loops on each one of the Post-it notes. And I asked students to walk around and using small Post-it notes write down what the output would be and kind of hide it from each other. So since we're COVID-y and we don't really want to walk around all touching all these different pieces of paper all over the room and stuff, we're going to try it on this Padlet thing instead. What that means is you might be able to see another group's answer. Don't assume they're right, because normally, and when we do it in the classroom, I make it where you can't see each other's answers, which kind of makes people search out their own answer a little bit better. But one of the worst things you can do in programming is look at somebody around you and assume they're right, because they might be so far, they're probably right, because you guys are pretty good, but they could be wrong. So try not to look at anybody else's comments in there as you're doing it, so that your group can benefit from it the most. There's 8 or 10 of them. There's some weird for loops. I tried to find weird ones and ones that you would really have to think about to figure out what the output would be, because we want to really not be surprised by these things when we see them in the wild, right? We want to kind of know what to expect. So that one is a little bit unusual. I wanted to show it to you. That's only 20 minutes of lab time, but we will have almost the majority of our time next time for lab time. So let me know if you have any questions. Everybody good with that? All set to go? All right, thanks guys. I'm gonna end this thing.
Until further notice, that's all you did. Later on.
So I am like,
Yeah,